You've spent your entire life believing in a cosmic lie, and I'm going to destroy that illusion right now. Because light is not the fastest thing in the universe, and when you understand what really surpasses the speed of light, your mind will never work the same way again. So sit back, take a deep breath, because this journey through the 30 most mind-blowing curiosities of the cosmos will completely transform the way you see reality before you fall asleep tonight. Neil deGrasse Tyson has spent decades explaining the mysteries of the universe in a way that makes the average person feel like an astrophysicist. And today, I'm going to take you on that journey using exactly that style that turns impossible concepts into synapse-exploding revelations. Because the universe isn't just weird, it's more absurdly bizarre than any science fiction ever dared imagine. We then start with this first bomb that overturns everything you learned in school. The speed of light travels at approximately 300,000 kilometers per second. This means that in a single second, a photon can travel 7.5 times around the Earth. It seems impossible to overcome right, wrong, because there is something in the universe that makes light look like a turtle crossing a hot asphalt road on a summer Sunday. Space itself can expand faster than light, and this does not violate any laws of physics. Einstein said that nothing can travel through space faster than light, but he never said that space itself cannot expand at absurd speeds. And that is exactly what happens in the most distant regions of the observable universe. Galaxies are moving away from us at speeds that exceed 300,000 kilometers per second. Not because they are moving through space so fast, but because the very fabric of space-time between us, and they are stretching like cosmic rubber being pulled by invisible hands. This means that there are galaxies in the universe whose light will never reach us, no matter how long we wait, no matter how advanced our telescopes become. They are lost to us forever, trapped behind a cosmic horizon that expands faster than any light message can travel. And if you're out there thinking that's crazy, rest assured the journey is just beginning. If you're the type who loves to have your mind blown by scientific revelations like me, subscribe to the channel now, because we have many more mind-blowing discoveries to share with you in the coming weeks. And believe me, what comes next in this itinerary will make this first curiosity seem like a piece of cake. The second curiosity that Neil deGrasse Tyson loves to explain is about time. And here things get really disturbing for those who are about to sleep. Because time doesn't pass at the same speed for everyone. This is not cheap philosophy. It is proven physics with atomic clocks on planes and satellites. If you put two perfectly synchronized clocks, leave one on the surface of the Earth and send the other into space at high speed, when they meet again, they will show different times. The clock that traveled will be behind. It literally experienced less time. And this happens because the faster you move, the slower time passes for you in relation to someone who is standing still. The astronauts on the International Space Station who spend 6 months orbiting the Earth at approximately 28,000 kilometers per hour return home, having aged a few milliseconds less than the rest of us. They have literally traveled a little bit into the future. It's not science fiction, it's what happens every day up there. But it gets even weirder when you add gravity to the equation. Because gravity also distorts time, the stronger the gravitational field, the slower time passes. So if you could survive on the surface of a neutron star, where gravity is billions of times stronger than on Earth, 1 second for you would be equivalent to years passing here. You could watch entire civilizations be born and die while eating your cosmic breakfast. The third curiosity takes us inside your own body, and this is one of Tyson's favorites because it connects the infinitely large with the absurdly small. Every carbon atom in your cells, every oxygen molecule in your lungs, every iron particle in your blood was forged in the core of a star that exploded billions of years ago. You are not just in the universe observing it from the outside. You are literally the universe observing itself. made of stardust that organized itself in such a complex way that it developed consciousness. And now you are lying in a bed, thinking about your own cosmic origins. This is poetry, written with nuclear physics equations. When a massive star dies in a supernova, the temperature and pressure at its core becomes so extreme that light elements like hydrogen and helium are fused into heavier elements. Carbon, oxygen, nitrogen, iron, all the ingredients needed to build rocky planets and living things like you and me. So the next time someone asks you where you came from, the scientifically correct answer is from the stars, and that's no metaphor. The fourth curiosity dives into black holes, and here Neil deGrasse Tyson really gets excited, because these objects are the biggest cosmic trolls out there. They literally break our intuition about how the universe should work. A black hole is not a hole in the traditional sense. It is a region of space where gravity has become so intense that not even light can escape. Imagine compressing the entire mass of the sun into a sphere the size of a small city. The gravity on the surface would be so absurd that it would distort space-time in ways that make your head spin. If you were to fall towards a black hole, something bizarre would happen depending on who is watching. For you who are falling, everything would seem relatively normal until you get too close and get spaghettified. Yes, that is the real technical term. The tidal forces would stretch you like cosmic spaghetti. But to someone watching from afar, you would never actually fall into the black hole. The time dilation would be so extreme that they would see you frozen at the edge of the event horizon, getting redder and darker until you disappeared from view, but never actually crossing that boundary. It's as if the universe has created a door that seems impossible to pass through from the point of view of any outside observer. The fifth curiosity is about the vacuum of space, and this goes against everything science fiction films have taught you. The vacuum is not really empty. It is teeming with quantum activity that defies common logic. Heisenberg's uncertainty principle allows particles and antiparticles to spontaneously emerge from nothing, exist for unimaginably small fractions of a second, and then annihilate each other back into nothingness. This happening constantly in every cubic centimeter of seemingly empty space. These quantum vacuum fluctuations have been experimentally proven through the Casimir effect, where two metallic plates placed extremely close to each other in a vacuum are pushed together by a mysterious force. This force exists because there are fewer quantum fluctuations between the plates than outside them, creating a pressure that brings them closer together. Nothing literally pushes physical objects. The sixth curiosity takes us to size scales that will fry your brain before bed, and Tyson loves using this one because it puts humanity into perspective in a way that is simultaneously humbling and inspiring. If you could travel at the speed of light, it would take 8 minutes to reach the Sun, 4 years to reach the nearest star Proxima Centauri, 100,000 years to cross our galaxy to the Milky Way, and 2 million years to reach the nearest large galaxy, Andromeda. And our galaxy is just one of approximately 2 trillion galaxies in the observable universe, each containing hundreds of billions of stars, each star potentially surrounded by planets. It's a number so absurdly large that if you tried to count every star in the observable universe spending 1 second per star, it would take longer than the current age of the universe. The seventh curiosity is about something that makes up most of the universe, but that no one has ever seen directly: dark matter. And this is one of the greatest humiliations of modern physics, because we basically admit that we have no idea what 85% of the matter in the cosmos is. We know dark matter exists because we can see its gravitational effects. Galaxies spin too fast for the amount of visible matter they contain. They should fall apart, but they don't, because there is something invisible holding it all together. Something that doesn't emit light, doesn't absorb light, doesn't interact with anything except through gravity. The eighth curiosity adds another mystery to the equation: dark energy, which is even stranger than dark matter and makes up approximately 68% of everything that exists. We discovered dark energy in 1998 when scientists observing distant supernovae realized something impossible. The universe is not just expanding, the expansion is accelerating. Something is pushing the cosmos outward faster and faster, and we have no idea what it is. So to recap, the normal matter that makes up you, me, the Earth, the stars, the planets, everything we can see and touch, only represents approximately 5% of the universe. The rest is a complete mystery. Divided between dark matter and dark energy, we basically live in a cosmos where 95% is unknown. This discovery is impacting scientists all over the world, and I'm wondering, where are you watching now? Comment on your city or country. It's incredible to think that we are all connected on this same planet, trying to understand a universe that hides 95% of itself from us. The ninth curiosity will make you look at the night sky in a completely different way. Because when you observe the stars, you are literally looking into the past, not metaphorically, physically. The light from the closest star to the Sun, Proxima Centauri, takes 4 years to reach us. So when you look at it, you're seeing what it looked like 4 years ago. If it exploded right now, we wouldn't know for another 4 years when the light from that explosion finally arrives. The light from the star Betelgeuse in the constellation Orion takes approximately 650 years to reach us. So we see it as it was in the Middle Ages on Earth. Kings and queens walked through Europe as this light began its journey to our eyes today. And the most distant galaxies we can observe with our telescopes are so far away that their light took more than 13 billion years to arrive. We are seeing the baby universe, galaxies forming when the cosmos was just a few 100 million years old. The 10th curiosity explores something that Tyson calls the most dangerous thing in the universe. And it's not black holes, it's gamma-ray bursts, explosions so violent that they release more energy in seconds than the Sun will produce in its entire life of 10 billion years. When a supermassive star collapses or two neutron stars collide, the result is a jet of gamma radiation so intense that it could sterilize any planet in its path thousands of light years away, simply boil the atmosphere, and destroy all complex life. The good news is that for a gamma-ray burst to affect us, it would need to be relatively close and pointed directly at us. The bad news is that we would have no advance warning. It travels at the speed of light, so it would arrive at the same time that we would know of its existence. The 11th curiosity takes us inside the atoms that make up everything, and here things get truly surreal because at the quantum level, the rules of the macro-universe simply don't apply. A particle can be in two places at once until you look at it. This is not uncertainty about where it is. It literally exists in multiple places simultaneously in a state called superposition. It is only when you make a measurement that it collapses to a defined position. Einstein hated this. He famously said that God doesn't play dice with the universe, but repeated experiments over decades have proven that yes, at the fundamental level of reality, there is genuine randomness that cannot be eliminated. The universe is probabilistic at its deepest essence. The 12th curiosity connects the quantum with something that looks like cosmic telepathy, quantum entanglement, where two particles become so connected that measuring one instantly affects the other, no matter the distance that separates them. If you entangle two photons and send one to the other side of the galaxy, when you measure the spin of one, you instantly know the spin of the other. 100,000 light-years away, information about the state appears to travel faster than light. But before you get too excited, we can't use this for faster-than-light communication because we don't control the outcome of the measurement. It's random, so we can't encode messages, but it's still a non-local connection that Einstein called ghostly action at a distance. The 13th fun fact is about something you experience every day, but never stop to think about its origin, gravity, and here Tyson likes to blow people's minds by explaining that gravity isn't really a force in the traditional sense. Einstein showed that gravity is actually the curvature of space-time caused by the presence of mass and energy. The Earth is not pulling you down. The Earth's mass is curving space-time around you in such a way that the most natural path for you to follow is towards the center of the planet. Imagine a bowling ball on a trampoline. It creates a depression in the fabric. Now roll a marble across the surface, and it will curve towards the bowling ball. Not because it is being pulled by an invisible force, but because it is following the curved geometry of the fabric itself. This is how gravity works in space-time. The 14th curiosity takes us to the beginning of everything, the Big Bang, which was not an explosion in space, but an expansion of space itself. And this distinction is crucial to understanding what really happened 13.8 billion years ago. There was no point in space where the Big Bang happened. The Big Bang happened everywhere simultaneously because there was no space outside of it. The universe did not expand into something. Space itself expanded, carrying matter and energy with it, and this expansion continues to this day. The most direct evidence of the Big Bang is the cosmic microwave background radiation, a microwave glow that permeates the entire universe and represents the oldest light we can detect, emitted when the cosmos was just 380,000 years old and finally cooled enough to become transparent. The 15th curiosity questions something fundamental about reality, and this is perfect to reflect on before bed, because it may be that our universe is just one of infinite universes in a larger multiverse. Some interpretations of quantum mechanics suggest that every time a particle can go one way or the other, the universe splits, and both possibilities play out in parallel realities, each quantum decision creating infinite branches of alternative histories. Other theories suggest that our universe may be like a bubble in an ocean of bubbles, each with its own physical laws, different fundamental constants, some where life would be impossible, others where forms of existence we can't even imagine could flourish. The 16th curiosity is about the finiteness of the observable universe versus the possible infinity of the total universe. And this distinction is important because what we can see is not everything that exists. The observable universe is approximately 93 billion light-years in diameter. But that is only how far light has had time to travel from the Big Bang to us. Beyond that horizon, there may be infinitely more space, more galaxies, more stars, more planets, more possibilities. We simply cannot see it because the light from there has not yet arrived and may never arrive due to accelerated expansion. The 17th curiosity delves into the final fate of the universe, and here we have to accept that all the options are a little depressing from a human point of view, but fascinating from a scientific point of view. The most likely scenario based on current evidence is heat death, where expansion continues forever. Stars eventually stop forming when all hydrogen is consumed. The last stars die. Black holes slowly evaporate through Hawking radiation, and the universe becomes a cold, dark void, eternally approaching absolute zero. This process would take something like 10 to the 100th power of years, a number so large that the current age of the universe is insignificant in comparison. Basically, the universe will exist in eternal darkness for much longer than it existed with light. The 18th curiosity talks about something that is happening right now. As you listen to this, the Moon is moving away from the Earth approximately 3.8 centimeters per year. This seems small, but over billions of years it has enormous consequences. About 1.5 billion years ago, the Moon was much closer, and days on Earth were only 18 hours long because the planet rotated faster. The tides were much more extreme. and the moon dominated the sky in a way that would have been terrifying and magnificent at the same time. In the distant future, the moon will be so far away that it will no longer be able to completely cover the sun during eclipses. The total eclipses we are lucky enough to witness now are a temporary cosmic coincidence that will not last forever. The 19th curiosity explores the extremes of density in the universe, and here the numbers become so absurd that they lose intuitive meaning. A teaspoon of material from a neutron star would weigh approximately 6 billion tons on Earth, because electrons have been squeezed against protons to form neutrons packed so densely that normal matter appears to be made of empty space by comparison. And if you compress that neutron star even further, it collapses into a black hole where all the mass is theoretically compressed into a point of infinite density called a singularity, where the laws of physics as we know it simply stop working. The 20th curiosity is about how speed affects not only time, but also mass. And this is one of Einstein's most counterintuitive predictions that has been proven countless times in particle accelerators. The faster an object moves, the more massive it becomes, not because it is gaining matter, but because the kinetic energy adds to what we call relativistic mass, and that is the reason why nothing with mass can reach the speed of light. To accelerate something to the speed of light, you would need infinite energy because the mass would increase infinitely as it went. If you approached this limit, it is a fundamental barrier of the universe, not a technological limitation that we could overcome with better engineering. Particles in the Large Hadron Collider are accelerated to 99.99% of the speed of light. And at that speed, a proton has approximately 7,000 times more energy than it would have at rest. This extra energy manifests as additional mass. The 21st curiosity talks about exoplanets, and here we enter territory that would have been science fiction just a few decades ago, but is now routine observational science. Until 1992, we had no confirmation of any planet outside our solar system. Today we know of more than 5,000 confirmed exoplanets, and we estimate that there are more planets than stars in our galaxy, perhaps trillions in the Milky Way alone. Some of these planets orbit in the habitable zone of their stars where liquid water could exist on the surface. Some are rocky like Earth, others are gas giants larger than Jupiter. There are worlds with 2 suns in the sky, planets that orbit dead stars, diamond worlds, oceanic planets. The diversity is dizzying. The 22nd curiosity questions are cosmic loneliness, and this is the big question that Tyson often addresses. If there are so many potentially habitable planets, where is everyone? Why don't we detect signs of alien civilizations? The Fermi paradox points out this contradiction. Given the size and age of the universe, technological civilizations should have arisen elsewhere and had time to colonize the entire galaxy. But we see no evidence of them. The silence is deafening. Explanations range from the optimistic to the terrifying. Perhaps intelligent life is extremely rare. Perhaps civilizations self-destruct before they spread. Perhaps we are being observed but not contacted. Perhaps physics makes interstellar travel impractical. Or perhaps we simply haven't looked properly yet. If these questions are making your mind travel as much as mine, tell me in the comments which theory about the existence of alien life you find most convincing. I love reading your reflections on these topics that make us question our place in the cosmos. The 23rd curiosity takes us back to our own planet for a humbling perspective. The Earth rotates on its axis at approximately 1,670 kilometers per hour at the equator. It orbits the Sun at 107,000 kilometers per hour. Our solar system orbits the center of the Milky Way at 800,000 kilometers per hour. And our galaxy moves towards the Great Attractor at approximately 2 million kilometers per hour. You are standing still reading or listening to this, but in reality, you are moving in multiple directions at absurd speeds simultaneously. never occupying the same point in space for 2 consecutive moments, the universe does not allow you to stand still. The 24th curiosity explores the concept of antimatter, and this substance seems like something out of science fiction, but is completely real and can be created in laboratories on Earth. Antimatter is like normal matter, but with opposite charges. A positron is identical to an electron, except that it has a positive charge. When matter and antimatter meet, they annihilate each other, converting all their mass into pure energy. 1 gram of antimatter reacting with 1 gram of matter would release energy equivalent to approximately 43 kilotons of TNT, more powerful than the Hiroshima bomb. So antimatter is theoretically the most efficient fuel possible. The big mystery is why the universe is made almost exclusively of matter. The Big Bang should have created equal amounts of matter and antimatter that should have annihilated each other, leaving only energy. But for some reason, there was a small excess of matter, approximately 1 extra particle for every billion pairs that annihilated each other. And this residue is all that exists today. The 25th fun fact is about neutrinos, the ghost particles that pass through everything as if solid matter didn't exist, and trillions of them are passing through your body right now as you listen to this. Neutrinos almost do not interact with normal matter. A neutrino could pass through a lead wall a light year thick and probably not hit anything. They are the loneliest cosmic travelers, produced in nuclear reactions on the sun, in supernova, in nuclear reactors, permeating the entire universe. To detect neutrinos, scientists build gigantic detectors filled with ultra-pure water deep inside ancient mines, hoping that on the very rare occasion a neutrino will interact with an atom and produce a detectable flash of light. It's like trying to catch ghosts with buckets of water. The 26th curiosity addresses the nature of time in a way that will keep you awake thinking, because at the fundamental level of physics, equations work equally well forward and backward in time. There is nothing in the basic laws that distinguishes past from future. So why do we experience time flowing in only one direction? Why do we remember the past but not the future? Why broken eggs do not reconstruct themselves spontaneously? The answer lies in the second law of thermodynamics and the increase in entropy. The disorder of the universe always increases. At the time of the Big Bang, the universe was in a state of extremely low entropy, highly ordered, and since then, it has evolved to states of increasingly greater entropy. It is this progression that defines the arrow of time, not something fundamental in the equations, but a consequence of the initial conditions of the cosmos. The 27th curiosity talks about the smallest unit of time that makes physical sense, Planck time, which is approximately 5.4 times 10 raised to minus 44 seconds, so small that our mind cannot conceive. If you divided a second into Planck times, it would have more units than all the seconds that have passed since the Big Bang. It is the scale where quantum mechanics and gravity meet, and our current theories stop working properly. Below that time scale, concepts like before and after can lose meaning. The fabric of space-time can become frothy and indeterminate. It's the frontier of knowledge where we need a theory of quantum gravity that we don't yet have. The 28th curiosity takes us to the mysterious cosmological constant, the value that describes the energy density of the vacuum of space and which is directly linked to the accelerated expansion of the universe. When physicists try to calculate theoretically what the value of vacuum energy should be based on quantum mechanics, they get a number that is 10 to the 120th power times greater than the observed value. This is possibly the worst prediction in the history of physics. This absurd discrepancy is called the cosmological constant problem, and no one knows how to solve it. Either something is fundamentally wrong with our understanding, or the vacuum energy is cancelled out by some unknown mechanism. It is one of the greatest unsolved mysteries in theoretical physics. The 29th curiosity is about the possibility that we live in a simulation, And although it seems crazy, some physicists and philosophers take this hypothesis seriously. The argument is statistical. If advanced civilizations eventually develop the ability to simulate entire universes with artificial consciousnesses that they think are real, then there would be many more simulated universes than the single base universe, making it statistically more likely that we are in a simulation. We have no way of definitively testing this, but it is interesting to note that reality appears to behave like a simulation. In some respects, quantum mechanics suggests that properties do not exist until measured as if the universe were saving processing. And there are fundamental limits to resolution in space and time at the Planck scales. The 30th and final curiosity is perhaps the most profound of all, and it is the fact that you exist to contemplate these wonders, that star-forged atoms have organized themselves in such a complex way that they have developed consciousness capable of looking at the universe and trying to understand it. Neil deGrasse Tyson often points out that we are the means by which the cosmos knows itself. We are not external observers of the universe. We are part of it, having a subjective experience. Billions of tons of atoms of carbon, oxygen, hydrogen, nitrogen, and dozens of other elements working together in such a coordinated way that what we call mind emerges. When you look at the stars, they are atoms from dead stars forming eyes and brains to contemplate living stars. The universe has developed structures capable of contemplating its own existence. This is not poetry. It is a literal description of what is happening. And here we come to the end of this journey through 30 curiosities that I hope expanded your mind before bed. And if you got this far, if you let your imagination travel through the galaxies and quantum mysteries, if you questioned your place in the cosmos and felt that shiver of wonder that only real science can provoke, then this content has fulfilled its purpose. If these revelations blew your mind as much as they blow mine every time I think about them, leave a like, subscribe to the channel if you're not already subscribed, and turn on notifications because we have many more mysteries of the universe to unravel together. Each video is a new journey through this infinitely strange and fascinating cosmos that we were lucky enough to emerge within. Now, let me give you one last provocation. Before you close your eyes, think with me. You spent the last few minutes absorbing information about the faster-than-light expansion of space, about time dilation, about ghost particles passing through your body, about the possibility of infinite parallel universes, about the fact that 95% of the cosmos is completely unknown. You absorbed all of this using a brain that evolved to find fruit in the African savanna and avoid predators, a brain that was not designed to contemplate singularities or quantum superpositions, but that somehow manages to do so, can abstract, theorize, imagine realities beyond immediate experience. This in itself is a curiosity that I did not include in the 30 because it deserves special mention. The human brain's ability to contemplate the incomprehensible is perhaps the greatest evidence that the universe can produce complexity beyond what seems possible. If atoms can organize themselves into structures that think about atoms, what limits there are to what can emerge from the laws of physics? So when you close your eyes tonight, remember that you are lying on a planet spinning at over 1,000 kilometers per hour, orbiting a star at 107,000 kilometers per hour, in a galaxy moving at millions of kilometers per hour through an acceleratingly expanding universe, made of dust from stars that died billions of years ago, contemplating mysteries that defy the most fertile imagination. You are not too small to matter. You are the universe having a human experience, and that is extraordinary. Thank you for taking this journey with me. Sleep with an expanded mind, dream of galaxies and black holes and multiverses, and remember that tomorrow there is more science to explore together. Good night, and see you in the next video. Before you sleep, reflect on this. Every second that passes, 150 million tons of solar matter are converted into energy in the Sun's core through nuclear fusion, hydrogen turning into helium releasing photons that will take 100,000 years to reach the solar surface and then only 8 minutes to travel to your eyes. The light that brightened your day today began its journey in the core of the Sun before any human civilization existed, before the pyramids, before writing, before agriculture. This light was already trying to escape the dense interior of our star as mammoths roamed the Earth. And that same light, after a journey of hundreds of thousands of years, ended its cosmic journey by hitting your retina for a split second as you looked out the window. What an extraordinary fate for a photon, to travel through astronomical eons to deliver a message from the Sun to the consciousness of a being made of stardust. Now multiply that by the octillions of photons that hit Earth every second, each with their own epic journey, and realize that we are constantly being bathed by cosmic messengers carrying the energy that powers all life on this planet. The photosynthesis that produces the oxygen you breathe exists because plants have learned to capture these stellar travelers and transform their energy into chemistry. Speaking of breathing, every time you breathe in, you are inhaling molecules that have passed through the lungs of practically every human being who has ever lived. The Earth's atmosphere is a shared reservoir, recycling the same atoms for billions of years. You are breathing in atoms that Cleopatra breathed, that dinosaurs breathed, that the first bacteria recycled. And these oxygen and nitrogen molecules were not here in the beginning. Earth's primordial atmosphere was completely different, toxic to any form of life we know today. It was life that transformed the atmosphere over billions of years. Cyanobacteria learned photosynthesis and slowly poisoned the air with this reactive and dangerous gas called oxygen, causing one of the greatest mass extinctions in Earth's history. The Great Oxygenation Event that killed almost all existing life, but paved the way for complex organisms like you and me, that we depend on this poison to survive. Think of the cosmic irony. The same atmospheric transformation that was a catastrophe for life 2 billion years ago is now absolutely essential to our existence. Traumatic events on a planetary scale are often the catalysts for new possibilities. The extinction of the dinosaurs 66 million years ago made room for small, insignificant mammals to eventually evolve into primates and then humans gazing out into the cosmos. In fact, this asteroid that wiped out the dinosaurs was approximately 10 kilometers in diameter and hit the Earth at around 20 kilometers per second, releasing energy equivalent to billions of nuclear bombs, vaporizing rock, setting forests on fire around the world, blocking the sun for months or years, collapsing food chains. It was a very bad day to be in. I live on this planet. But here's the cosmic perspective. This type of impact is not rare on a geological timescale. It happens periodically. Asteroids and comets regularly cross Earth's orbit. We are literally going through a cosmic firing range. The question is not if another big impact will happen. It's when, in thousands, millions, or hundreds of millions of years. That's why there are programs like NASA's DART, which in 2022 demonstrated that we can deflect asteroids by crashing a spacecraft into them. This is the first time in history that a species has developed the ability to protect itself against extinction by impact. We are the first dinosaurs with a defense plan. But there are threats that we cannot dodge, such as nearby supernovae. If a massive star within approximately 50 light-years were to explode in supernova, the radiation could devastate the Earth's ozone layer, increasing surface UV radiation to levels lethal to many organisms. Fortunately, there are no supernova candidates that close within the next few 100,000 years, at least not that we know of. There are also targeted gamma-ray bursts that we mentioned before. Magnetars with magnetic fields trillions of times stronger than Earth's that occasionally release dizzying bursts of energy. supermassive black holes that, when active, can sterilize entire galaxies. The universe is a dangerous place for fragile life forms like us. But perhaps the most likely danger is what we do to ourselves. Climate change, nuclear weapons, engineered pandemics, uncontrolled artificial intelligence. We are the first species in Earth's history with the capacity to deliberately or accidentally extinguish ourselves through our own actions, a power that comes with commensurate responsibility. Now let me tell you something comforting. After all this cosmic catastrophism, life on Earth has survived practically everything the universe has thrown at it in the last 4 billion years. Giant impacts, extreme volcanism, global ice ages, extinction events that have eliminated more than 90% of species. And yet here we are. Life is stubborn, resilient, creative in finding ways to persist and adapt. And even if humanity eventually disappears, whether by our own doing or by some cosmic event, the laws of physics that allowed atoms to organize themselves into conscious life here have probably allowed it in countless other places in the cosmos. Consciousness may be a common feature of the universe, not a rare anomaly. Going back to smaller but equally fascinating scales, did you know that you have more synaptic connections in your brain than stars in the Milky Way? Approximately 100 trillion synapses compared to a few hundred billion stars. Your brain is more complex than a galaxy in terms of connectivity. Every thought you have, every memory you access, every sensation you experience is a pattern of electrical and chemical activity traversing this network of connections. You are literally an electrochemical storm happening inside a shell of bone, processing information from the external environment and generating responses. An internal universe of subjective experiences emerging from purely physical interactions between neurons. And here we come to the so-called hard problem of consciousness. We can completely describe the functioning of the brain in terms of chemistry and physics. We have mapped regions responsible for different functions. We understand how neurons communicate, but we have no idea how electrical activity in biological tissue produces subjective experience. The sensation of redness when seeing red, the pain of a burn, the joy of a discovery. Some scientists think that we will eventually understand consciousness in purely physical terms. Others think that there is something fundamentally different about subjective experience that requires explanations outside of traditional physics. Still others propose that consciousness may be a fundamental property of the universe, like mass or charge, present to varying degrees in all matter organized in certain ways. Whatever the answer, you are having a conscious experience right now, absorbing these words, forming thoughts, perhaps feeling sleep start to come. And this experience is real to you in a way that transcends any physical description. You don't just process information. You feel what it is to process information. There is something it is to be you. When you dream during REM sleep, your brain generates experiences as vivid as waking, but completely disconnected from external reality. You can fly, talk to people who don't exist, visit impossible places, all feeling completely real as it happens. Dreams demonstrate that your consciousness does not need the external world to have rich experiences. Your brain can convincingly simulate internal realities using only memories and neural patterns, raising the question of how to know for sure that wakefulness is not also an internally generated simulation, just more consistent and constrained by external sensory inputs. Philosophically, the only thing you can be absolutely certain of is that you are having experiences now. Descartes' famous cogito ergo sum, I think therefore I am, everything else, the external world, other minds, the past, the laws of physics, could theoretically be illusion, but the present experience of being conscious is self-evident. This philosophical journey is the kind of thing Neil deGrasse Tyson likes to explore at the edges between science and philosophy, where scientifically tractable questions meet mysteries we may never solve, where physics meets metaphysics. But getting back to the concrete before you fall completely asleep, let me give you one more perspective on timescales that will make your head spin. If you compressed the entire history of the Earth into a single year, the Big Bang would happen on January 1st, the Earth would form in mid-September, simple life would appear in October, but complex multicellular life would only emerge in November. Dinosaurs would dominate the planet in the last days of December and would go extinct on the morning of December 31st. All recorded human history, all civilizations, all empires, all wars, all works of art, all science, would happen in the last seconds before midnight. You are living in an infinitesimal slice of cosmic time, a blink of an eye on the scale of the universe. But that blink of an eye contains all of human experience, all of the love, all of the pain, all of the beauty and horror, all of the discovery and ignorance. It is simultaneously insignificant and infinitely precious, depending on the perspective you choose to adopt. And perhaps this is why science is so valuable. It gives us perspective. It shows us our real place in the cosmos without comforting illusions. But in doing so, it reveals genuine wonders that surpass any invented mythology. Verifiable reality is stranger and more fascinating than any fiction. So sleep knowing that you are stardust gazing at stars, that your every atom has billions of years of cosmic history, that you are connected to the entire universe through physical processes that we can understand and measure, that the same curiosity that made you watch this content is the universe trying to understand itself through you. Good night. Dream of multiverses and quantum particles and black holes and the infinite wonder of existing in an existence-permitting cosmos, and remember that tomorrow when you wake up, the mysteries will still be here waiting to be explored. Because the universe never stops surprising us when we decide to pay attention. And if you want to continue this journey of discovery, don't forget to turn on the channel's notifications so you don't miss any new videos. Each week we explore another corner of this infinite cosmos, and you won't want to miss out on the next revelations that we'll uncover together. Now close your eyes, take a deep breath, and let the gravity that is bending space-time around you hold you comfortably in this bed as our planet continues its eternal dance around the sun. A fifth-generation star carrying elements forged in previous generations of stars that died so that you could exist. You are the result of 14 billion years of cosmic evolution, of Big Bang hydrogen transformed into heavy elements via nuclear fusion, dispersed by supernovae, collected in molecular clouds, condensed in solar systems, organized into planets, evolved into conscious life. In you, processing these words with a brain made of the same protons that have existed since the first minutes of the cosmos. Good night, explorer of the stars, until the next journey through infinity.